Hi, welcome back to the lab. So I have a Toyota Corolla 2010, and in there comes, I'm not sure if it's factory standard or whatnot, but it doesn't matter. The model that I got, which was standard in that model, was to get a auxiliary input, which when I got the car was primarily used for, let's say, iPods or MP3 players. What happened was, after using this for several years, you'd plug in your little adapter jack and it would start going, and then one of the channels would cut out either the left or the right. I forget which one. I think it was the left one. At some point I said, well, there must be something broken inside of here, and so I ended up looking up what this part is. Hey, there we go. Adapter assembly stereo jack, model number 6615002010, which is probably 2010. Reference number is CAPS. Oh, I'm just gonna read it from here. CAPS 8663X, I think. Anyway, you can go look on it online. It's easy enough to find the part and the model for your particular vehicle. But anyway, I said, well, I looked up the part and it was $100. $100 for this little thing here, which, I'm sure that you'd go walk into Toyota and they would gladly and happily replace this for you for $98 plus the labor to pull the entire center console panel apart to get at it and replace it. So I said, well, it must essentially be some sort of a broken connection. And indeed, when you look at the schematic for this, because they actually have the blow up diagram for this, exploded diagram, sorry, not blow up. There's a little circuit board, and that's exactly where the jack is resting. And the jack has mechanical support partially from the case, but mostly from the circuit board. Okay, so what's going to happen when you plug the jack in here and you go and wiggle it or whatever, and it gets whacked and banged? It's going to transfer all those forces into the circuit board and all the solder connections, because those are the only connections that are holding it. So of course that's where it's going to break. And indeed, I'm suspecting that's exactly where this is going to break. So let's open this and take a look. So I didn't look online. I just pulled it out and said, okay, well, I looked online to see how to pull it out, and that's you can look up videos on how to do that. That's not hard. But to actually open it up, I didn't find anything obvious, and I didn't look. So, well, when I looked at it and did a quick inspection, there's a connector in the back. There's the headphone jack in the front, and there are two sets of clips. There's a clip here, the same one on the other side, and there's a clip, here towards the back, right near the back, and here. Now I took a quick guess, and moving this around, the front face moves this clip here. So I said, well, maybe I'll try and see if I can get that off first. So what I normally do is use a spudger, push down, so apply some force in this direction, not too much, but a little bit, and then you'll see it'll pop up, and then hold, oops, of course, apply some force, holding it. You can use a spudger or whatever, flip it around, and then come and do the exact same thing on the opposite side, and it should come right out. So that's the front cover. I'm going to throw that away, don't need that. And inside we have, lo and behold, a jack, and again it's soldered directly to a small little PCB. So what I found out is you just take this and push that connector in the back. This will come, I think it comes right out. I'm not 100% sure. I might have to wiggle it a little bit. Or maybe it goes better out the other way. Or maybe that's what this clip here is for. Oops, sorry. This clip here is to, when you pop this piece out, it can just slide right out. But in this case, I don't think we will need to do that. So I'm going to bring you in close here. There's a couple of connections that are causing issues. If I'm wiggling it like this, okay, well, maybe you can't see it. This connection here, and I'm thinking for safety, this connection in the back. So it looks like there's a couple of tabs. Perhaps this one, maybe this one, although maybe it could be an internal trace too, and the one in the back here, but those might be structural tabs. These two in the back are obviously, they're cracked and they're moving as I move the connector. So what I think I'm going to do is I'm going to get in there with a soldering iron, and I don't know if the safe bet would probably be to remove this. If you come in inside and go under here, and pry it out like this, it'll pop that out. So that'll allow us to get in and get that part out, which means this whole assembly will come out clean. And there you go. So you can see that it's got a couple of resistors and 2 connectors on it. Like, this is clearly not the thing you should be paying somebody $100 for, especially since if you have any, any kind of basic soldering skills and assembly disassembly skills, you can, do something about this. All right, I'm going to get this mounted up, and we're going to solder that. So I mounted this on here, and I don't know if you can see this kind of wiggle here. But both of these pins here, which are definitely connected to signals, they're connected to I think this pin here and this pin here. These two are definitely signal pins, and they're definitely cracked. This one's cracked as well, but I don't think it's actually a signal pin. This one might be for stability or for mounting purposes, same as this one. So what I've got here is some 6337 solder, 0.38 millimeter because we're in Canada. It's just standard, regular rosin core style, flux, all that kind of junk, good stuff, solder. The important part is to have it nice and small and thin like this. So what we're going to do, and I also have Metcal handpiece with homebrew do-it-yourself soldering power supply. You can use anything though. This is really simple stuff. So preferably not one of those huge 150,000 watt, 100 watt guns you use for doing big heavy work. But like one of the 25 watt pencil sticks or something like that, or 15 watt will be fine. Traces are all nice and thin. Okay, so what I would do first is I'm going to put a little bit of extra flux on here just to make life a bit easier. But you don't have to. There will be flux inside the actual solder, so it's up to you. But I like to make my life easier. And I'm going to add a large amount of flux. So you heat up the joint, you add your solder. Not a large amount of flux, a large amount of solder, sorry. And you let that cool. Now that's a nice huge fillet. So that will be a little bit more structurally secure now too, which is good. And again, we'll do the same thing for the pads here. Pop off. And down here. Now, here's something I'm going to actually desolder this and see if you can see this, because this is something I just noticed. But it looks like the pads are not all the way, they're not very tight. There's a big hole around them. I'm just going to see if I can't get rid of some of the solder. Get rid of some of the solder first. So I don't know if you can see this. This is very interesting. It's almost like the pin is too small for the hole. Can you see this moving? I'm going to try and see if... Yeah. So you can see this moving here as I'm doing it. The actual hole that goes in the circuit board, it seems like it's too large. And there's, so there's a fair amount of gap between the edge of the hole and the actual pin, which means that if you don't put enough solder in there, it'll only be a very thin amount of solder. If you look at the other side of the board, there's actually no corresponding tinned pad on the other side, which means when you're soldering it, the only thing that you've got is the solder wicking down on the pin from this side. And if you've got a very large gap between the pin and the circuit board, that means that there's just a potentially very thin layer of solder that's holding that pin into into the actual board. And to use that as a mechanical joint is insane. So I would say that this board's actually fairly badly designed. It should have probably had pads both sides, and there are pads on the other side, so it wasn't sort of oh, it's a single-sided board. No, there's traces on the other side, so they could have easily put a pad on the other side Maybe if they didn't have anything to connect, maybe increase the pad size a bit to give it a lot more purchase on that side of the boards, so that it would act as an anchor, and the solder would then not only just reflow on the top here, but all the way down into the hole, along the pin and out and around the pad on the other side, so providing a nice solid mounting point right through the circuit board. But they didn't do that, so that kind of blows. So you're going to end up having this, where you have a very lean mechanical connection, and if you have any quality or defect during manufacture, which I would say could be the case here, you're going to have very little strength in the joint. And that's all. So this should be repaired now. Functionally it should work, but unfortunately I think that the issue is going to come back, especially if you start cranking on this pretty hard. I will call that successful repair. I mean, obviously I have to go try it, but it was clear that that's the problem, especially when I saw the symptoms and whatnot. That's a really easy thing you can do. If you can open up your central console, if you have this problem, which is you plug in your audio jack and you turn around and you lose one or two of the channels, simply open up the panel, pop this piece out. It's all clipped in. There's no magic. Like I said, unclip the front, and then just go ahead and do a quick reflow. Add a bit more solder to each of the pad. Make sure you don't bridge anything, because that would be bad. Use a bit of flux if you need to. Whatever. Don't use the flux you would use for like pipes or anything like that. Go find an electronics flux, or like I said, just use the flux inside of your solder. It should be more than enough. And just put a bit of extra solder in there. Don't rush the joint. Heat it up first. Let the solder melt. Add more solder. Then you should be good to go. And then as a final thing, what you may want to do is just buzz out. You can look at the circuit diagram. I believe it's online. You can buzz out with a multimeter and make sure that there's connectivity and no shorts where there shouldn't be. Good luck, and yeah, nice simple fix. Save $100.